Good morning, ViPR chemistry students. Hey, let's take a look at Unit 2, Section 1. Basically, let's take a look at our slides here. So there were some great thinkers in the history of man, even back to the Greek times, 400 BCE, before the Common Era. And one of those thinkers, philosopher Democritus, he believed if you cut things up into smaller pieces, it would basically result in tiny particles. And so he's really the first person to talk about that idea. The word atom is the Greek word for small particles. So he was a contributor. Aristotle, not so much. He believed that the world was more continuous, but he is a great thinker in the sense that he was thought of as the father of logic and reason. So he advanced science ideas in his time. So quickly going through here, really moving on up to the 1800s, John Dalton is kind of given credit for the person who really is the first person to really ever outline the model of the atom. Now, he used Lavoisier's ideas of law of conservation of mass. Like if you had a chemical reaction, really the mass going into the chemical reaction would be the mass coming out on the other side. So there's that idea. I'm moving pretty quick here. Proust was another one that contributed. He was the one who, he looked at things like compounds, and it's always the same percentage by element. So in the case of salt, 39.3% sodium and 60.66% chlorine, that never changes. And so he established that. And then we have Dalton himself, who had the idea of multiple proportions. The law of multiple proportions says that you can't just have a part of an atom. So like, for instance, H2O, you can have two hydrogens and one oxygen, but not part of one. And so that's kind of that idea. Now, when we compare what we know today in the modern theory of the atom, we see basically similarities to Dalton's theory, but there are some differences. So we can take a look at like what is different. And what we know today about atoms is that, yes, they are similar to each other, but some elements, we would say they're all the same, except they may be different in the number of neutrons they have. And so those become what we call isotopes. And so we'll get into that, as we get into this a little further. Also, we know much more about nuclear chemistry, where we know that we can actually destroy an atom or turn it into energy through nuclear reactions. All right, so I'd like for you to look all that over, and those are the ideas for Unit 2, Section 1. Thanks.